Well, thank you for joining me on this question. We're going to be looking at a similar question as the last one, but this time we're going to look at question 12. And it says repeat the previous question with events A and B as before, but now with the event C being that of a total obtained being 7. So let's refresh our memory. Probability of A, event A was obtaining an even number with a blue dice. An even number with a blue dice. Obtaining an even number with a blue dice. So this is not an even total, this is an even number with a blue dice. So it's almost like, are we talking about an even total or an even number? Let's just say an even number with a blue dice, meaning we get an even number with a blue dice, which means the blue dice could be a 2, a 4, or a 6. So it's all of these possibilities where the red dice could be anything but the blue dice could be 6, or the red dice could be anything and the blue dice is 4, or the red dice could be anything and the blue dice is 2. So that's if I've interpreted this correctly. Probability of A, here there are 18 out of 36 possibilities when you roll 2 dice that the blue dice is an even number. So that's a half. And let's look at part B. We want getting an even total. An even total. So therefore, green, I'll use green. Even total, getting a 1 and a 1. Getting a 3 and a 1, that makes 4. 5 and a 1, that makes 6. 2 and a 2 is a 4. 4 and a 2 is a 6. 6 and a 2 is a 8. 1 and 3 is 4. 3 and 3 is 6. 5 and 3 is 8. 2 and 4 is 6. 4 and 4 is 8. 6 and 4 is 10. 1 and 5 is 6. 3 and 4 is 8. 5 and 5 is 10. I don't know why it's disappearing. 2 and 6 is 8. 4 and 6 is 10. Okay. They're all the ways to get an even total. So let's put that as being the probability of getting an event B. There are 18 ways out of 36 where you get an even total. That's a half. Now let's look at red being, the total is 7. So we could get a 6 and a 1, 5 and a 2, 3 and a 4, 3 and a 4, 2 and a 5, 6 and a 1. It's the diagonal. We get a score of 7. So the way we can get a score of 7, there are how many ways? There are 6 ways out of 36. So that's 1/6 of getting event C. Well, let's see how this works. We've already established that event A and B are in fact independent. But let's see about B and C. You have to look at the earlier video to check out the probability event of A and B. Now the probability of B has to equal the probability of B given C. Now we've already established the probability of B is a half. But let's look at the probability of B given C. So that means out of how many in set C, how many of those are set B? So in set C there are 6, right? They're the red ones. You can see there are 6. How many of those 6 are set Bs? Set Bs are the green ones. And we've got, no, well, that makes sense because B we want an even total. And we've got none out of those 6 will be an even score if the total is 7. So yeah, look, the probability of B, a half does not equal 0. Therefore, B and C are not independent. They are, in fact, dependent. They do affect each other. If C happens, then it changes the probability of B. All right, so let's look at A and C. Well, that means the probability of A. Does the probability of A equal the probability of A if C happens? Well, let's find out. We've already established that the probability of A is a half. But what's the probability of A if C happens? Now, that means out of all of the red ones in set C, how many of those are set A? So there are 6 red. How many of those red are yellow? Yes, that one there, 5, 2. That one there, 3, 4. That one there, 1, 6. There are 3 that are in fact where the blue dice is even. So if the score is 7, the probability of A is still half, no matter what. So whether C happens or not, the probability of A is still a half. So therefore, this is interesting. This means that A and C are independent. It doesn't matter. Independent. So that is true. All right, this was a very interesting question. Until next time, stay happy.